What's up, guys? Today we're talking about the present value of annuities. So what's an annuity? An annuity is basically it's a series of equal payments that are made at a regular interval over a period of time. So you can buy one of these annuities with a lump sum of money that you pay now, and that's basically buying yourself a regular fixed income that you'll be receiving in the future. For example, right now I'll buy a 10,000 Rand annuity that's paying me maybe 450 a month for the next 4 years. Just an example. So let's jump into these two formulas you see at the top of the screen. The one to the left was my favorite. I did most of my calculations with it. There's three others. This one, well, the two others are for future value, but this one to the right is just as good. You know, everyone has a preference. One to left, mine. So the two dots at the top, that just indicate that this is calculating the present value of our annuity for payments that we receive in advance, meaning that at the beginning of the month we would receive our payment, or at the beginning of each year, this annuity is paying out our our payment. And then the one to the right is payment in arrears, meaning at the end of the period, such as at the end of a month, like a salary, or this payment is paying us at the end of a year. So someone once told me that these two dots, if you think about these two dots, think about you see like these two D's, advanced dots, that kind of stuck with me. I hope maybe that sticks with you. Anyway, let's jump into the formulas. We check that both of them have an N. What this N means is that that's the number of payments. And maybe one payment each month for a year, that would be 12 payments, or one payment per year for 12 years, 12 payments. The I here is the interest rate, but then take note here that I said it's the interest rate per payment period. So these two, the I and the N in our formulas, they always need to match. So if we're receiving payments monthly, then this interest rate needs to be a monthly effective interest rate. If the N is yearly, it's going to be a yearly rate, and so on. So that's very, very important. Otherwise, it's not going to work. And then I'll get into the V just now. And yeah, both of them have the same N's and the same I's. Here's two definitions that I just wrote out, and notice how I wrote certain, the level certain payments. So these are more simple. We'll get into more complex ones in future videos where we're doing the life annuities, where we have to consider the statistics of a person being alive to receive annuity payments and so forth. But we don't have to worry about that now. Now it's just a constant guaranteed payment. So let's look, if we go back to the formula, I left out one letter here, the V's. There's a V there, and there. So what these V's are, the V is called a discounting factor. So this is what V stands for, what V represents. So what a discounting factor is, discounting is the reverse of compounding. But when we multiply a value by V, it's shrinking our money. We're using V to calculate the present value of some money that we may receive in the future. And it's vital to have some understanding of what's actually going on, because money that we receive today is worth much more than the same amount that we would be receiving in the future. You can imagine it as if your friend is saying that he can give you 1,000 Rand today, or 1,000 Rand in a month or in a year. We'd much rather take the 1,000 Rand today, because we could be earning interest or like doubling this money. Like Lord knows what we can do with it, but we can make it bigger, other than waiting a whole year or a month to get that 1,000 Rand. When we present value an amount, we are decreasing it. When we future value an amount, we're increasing it. That just accounts for the time value of money. And then another notation that we'll be dealing with, actually, I don't deal with this too much, but you should still know it. D, which we call the discounting rate. So that is the interest over 1 plus the interest. There's one relationship between the V and the D that I think is pretty important to know. It went D is equals to 1 take away V. I can do that proof quickly. Let me remember how it goes. Okay, let's start with, yes. So we'll start with this. This is our first step. And then what we're going to do is we're going to 1 minus v, and this side we're going to 1 minus 1 over 1 plus I. But this 1 we can rewrite as, well, 1 is equals to 1. Am I right? That's a mathematical statement. So now we're just going to plug that in. Right, now we can simplify that a bit. And there we go. We can notice that the right-hand side is equals to d. Now we have proved that 1 minus v is equals to d. Nice. So now I want to jump in to writing these two formulas out in first principles. We'll start with an annuity in arrears. And then we have the one in advance. So these are all, we can see that when receiving money in arrears, meaning at the end of a period, to get the present value of it, we'd have to discount it once. And then on our second payment, we'd be discounting it twice. Third would be 3 times until our nth payment, which we'll have to discount it n times. And then for the one in advance, our first payment, we're receiving it today. There's no discounting. Whatever we're receiving today, that is the present value. That's why we're putting 1. And then when one more period, in a period later, when we receive another payment, we just need to discount it once, twice, so forth, until we get to the n minus 1. And then from this, it's evident to see that you can see, and you can work that out for yourself, how money in advance is always going to be, the present value of advance payments will always be larger than the one of arrear payments, obviously with respective values. And then if we just do some mathematical gymnastics, we come up with this. Because if we go to the first, this one, the equation for the arrears payments, and if we just take out, no, if we go to the advance one and if we go to the advance one and we multiply it by v, then this would become v, this would become v to the power of 2 to the 3, and then this would just be v, right? And you see that would be the same as the arrears one. That's how that statement holds. So now when we talk about the future valuing, present valuing of annuities, we can also consider future valuing annuities, which comes with these two formulas. I don't have much to say about these two formulas. I never used them a lot. There's nothing wrong with using them. So I'll just write the I's, the V's, the N's are all the same. I'll write them out in first principles now so you can see it looks a bit complicated, but it's okay, you'll be fine. Yeah. And something worth mentioning, this one here would be 1 plus I to the power of 0. So this first one here is the future value of annuity paid in arrears, with paid at the end of a period. So you can think of, if we're working the future value and it's paid at the end of a period, obviously the last payment is paid at the end of this whole term, of the whole annuity term. So that's why this is a 1. And then, yeah, same for the one in advance. So it has the dots there, advance. And then here's some relationships between all 4 formulas that handy to know. Maybe you can make sense of it. You see how well you understand it. So now let's do some examples. Let's calculate the present value of the following using an 11% per annum interest rate. What I'll do is, for the first question, I'm also going to calculate the future value of it, not using the formulas, but showing you how I would have done it. Because as I said, I don't use these two SN formulas. I don't think I've ever used them, but you can. So the first question is an annuity of 2,000 Rand per month starting now with a 5-year term. What we're going to do is I'm going to write this out in first principles. Let's go. Notice that I wrote there 59. That's because in 5 years we're receiving monthly payments. So over 5 years, that would be 60 payments. But our first payment it's in advance. It says starting now. So that indicates in advance. So we're not discounting the first payment here. That's just going to be 2,000. But then the next one, we're going to discount it once by 1 month. The second one will be discounted twice by 2 months. And then the last payment will be discounted by 59 months. So now let's do some mathematical gymnastics to get this into a form. Maybe we can see what's happening. And now you can recognize this part here. If you look at this and we go back when we rewrote this formula in first principles, that's pretty similar. So that indicates that we're going to be using the advanced annuity, which we could tell from the question and everything. But it's nice to see. So now let's write it. Now for this interest rate, we were given an annual interest rate. However, we need a monthly interest rate because the payments are monthly. So now we'll just do a quick conversion. And plug that into the calculator. That's a long number, so what I'm going to do is I'll just call it the variable A. Put some variable A there. Now all I'm doing is I'm substituting the formula in. And remember, V is equals to 1 plus I to the negative 1. So now when we plug all of this into the calculator, we get an answer of I said I would also calculate the future value of this. So let's say the question asked for the future value after the 5-year term. So the future value what I would do is I would have calculated this present value, and now I'll do this. Now I'm just going to compound this. So this 1.11, this is 1 plus the interest rate of 11%, and I'll compound, because this was the yearly one, so I'm just going to compound it over the 5 years. Put this in the calculator, get so that would be the future value. Let's go to the next question. We're calculating the present value of a 6-year bond of 10,000 Rand nominal with an 11% coupon rate payable annually, redeemed at 120% of par. So let's just remember that we're using an 11% per annum interest rate. So 11% per annum. So here we have a bond, which is basically us. We're buying it from a company. We're giving it a loan to a company. We're purchasing this bond for 10,000 Rand, and then they're telling us we're going to receive it at 120% of par. That means that we're going to receive it back at 20% more than what we bought it for. So let's just do a timeline. It'll make a lot more sense. Here's a timeline. We have a term of, how long? 6 years. So at the end, this is a 6. Such a 0, 1. So we're receiving a coupon rate payable annually. We'll assume it's in advance. It's usually in advance. So here's one coupon, one more, and the last coupon would be there. And then we're going to have a last payment over here with this 120% of par, which would be 10K times 1.2, and then at the beginning there would technically be a downwards because we paid 10,000 for this financial product. So now when calculating the present value of this, so what a coupon is, sorry, these little lines that are going up here, this is basically some sort of a compensation that we're going to be receiving from the company because we borrowed them like that 10,000. So this is a little bit of a compensation. So let's calculate the present value. We'll start by calculating the present value of the redemption amount, which is this 10K times 1.2 at the end that I wrote there. So we put, so here I'm just going to be discounting it 6 times. We can just use the yearly one here. So it's going to be, that'll be 12,000. 6, we'll pop that in the calculator. Now let's go to the present value of the, so same as the previous question, I'm going to just write this in first principles, but now we're receiving these in arrears. So even our first payment, and these coupons are 11%, that means 11% of this nominal amount of 10,000. So 11% of that would be 1,100 Rand coupons we're receiving. Same as before, let's see if we can factor something out. Yeah, now we can see that this follows the first principles of the arrears formula. So now we just pop this whole thing into the calculator. Cool, so that's the present value of the coupons. And now to get the present value of this whole financial product, we want to estimate maybe if it's really profitable for us, if it's the right thing to be doing with the money. Let's check. So our total present value would be, so you can see, at the end of the day, the present value of what we'd be receiving is 11,000, which is like 1,000 Rand over the 10,000 that we initially borrowed to the company. So you can discuss, you'll think if it's worth it, if it's worth your time. So I hope this helped. In the next video, I'll be proving these 4 formulas from first principles, which is also pretty handy to know. Thanks. Enjoy.